Hey guys, welcome back to Click Academics. In today's video, I'm going to be teaching you guys how to solve this exponential problem. And make sure to stick until the end of the problem, where I have 3 bonus problems that are similar to this one, which you guys can try to solve. Alright, so I have 8 to the power of 6 times 5 to the power of 5. So for my solution, 8 to the power of 6, we can rewrite as 8 to the power of 5 plus 1, because 6 is the same thing as 5 plus 1. So now I have 8 to the power of 5 plus 1 times 5 to the power of 5. Now, if I have something in the form a to the power of m plus n, this is the same thing as a to the power of m times a to the power of n. So a to the power of 5 plus 1 is going to equal a to the power of 5 times a to the power of 1. Now this times 5 to the power of 5. Now, if I have something in the form a to the power of m times b to the power of m, this is the same thing as a times b to the power of n. So in this case, I have 8 to the power of 5 times 5 to the power of 5, and because these two have the same exponents, I can multiply these two. So this is going to equal 8 times 5 to the power of 5 times 8 to the power of 1. And now 8 times 5, this is 40. So now I have 40 to the power of 5 times 8 to the power of 1. And now 40 to the power of 5, well 40, this is the same thing as 4 times 10. So now I have 4 times 10 to the power of 5 times 8. And now if I have something in the form a times b to the power of m, it's the same thing as a to the power of m times b to the power of m. So in this case, 4 times 10 to the power of 5, this is going to equal 4 to the power of 5 times 10 to the power of 5. Now I have this times 8. Now 4, this is the same thing as 2 squared. So if I replace 2 squared with 4, I get 2 squared to the power of 5 times 10 to the power of 5 times 8. Now if I have something in the form a to the power of m to the power of n, this is the same thing as a to the power of m times n. So 2 to the power of 2 to the power of 5, that's going to equal 2 to the power of 10, because 2 times 5 is 10. Now I have this times 10 to the power of 5 times 8. So now 8 is the same thing as 2 to the power of 3. So now I have 2 to the power of 10 times 2 to the power of 3 times 10 to the power of 5. Now if I have something in the form a to the power of m times a to the power of n, this is equal to a to the power of m plus n. So 2 to the power of 10 times 2 to the power of 3, that's going to equal 2 to the power of 10 plus 3, which is 13. So now I have 2 to the power of 13 times 2 to the power of 5. And 2 to the power of 13, this is equal to 8,192. And 10 to the power of 5, this is going to equal 1 with 5 zeros. So 1, 2, 3, 4, 5. Now if I multiply these two, I get 8192, 0, 0, 0, 0, 0. So this is my answer. Alright, so I have x to the power of 16 minus 169 is equal to 0. Now x to the power of 16 we can rewrite as x to the power of 8 times 2, because 16 is equal to 8 times 2. And now if I have something in the form a to the power of m times n, this is the same thing as a to the power of m to the power of n. So x to the power of 8 times 2, that's going to equal x to the power of 8 to the power of 2 minus 169, this is the same thing as 13 to the power of 2. Now if I have something in the form a squared minus b squared, this is the same thing as a plus b times a minus b. So in this case, a is equal to x to the power of 8 and b is equal to 13. So now I have x to the power of 8 plus 13 times x to the power of 8 minus 13 is equal to 0. So now x to the power of 8 minus 13, this is the same thing as x to the power of 4 to the power of 2 minus the square root of 13 squared. And again, these two are both to the power of 2. Remember, if I have something in the form a squared minus b squared, this is equal to a plus b times a minus b. So in this case, I'm going to have x to the power of 4 plus the square root of 13 times x to the power of 4 minus the square root of 13. And now I have this with, remember, I still have my x to the power of 8 plus 13 from the start. So I have x to the power of 8 plus 13, and all of this is equal to 0. So now I have three equations here. I have x to the power of 4 plus the square root of 13 is equal to 0. I have x to the power of 4 minus the square root of 13 is equal to 0. And I have x to the power of 8 plus 13 is equal to 0. So for x to the power of 8 plus 13 equals 0, all I have to do is subtract 13 on both sides. These two cancel out. I'm left with x to the power of 8 is equal to negative 13. So now if I take the 8th root on both sides, these two cancel out, and left with x is equal to the 8th root of the square root of negative 13, or sorry, the eighth root of negative 13. And you actually can't take a positive root, or sorry, not a positive, an even root on a negative number. So this is wrong. So now for x to the power of 4 plus the square root of 13 equals 0, I'm going to first subtract the square root of 13 on both sides. So then these two cancel out. Now I have x to the power of 4 is equal to negative square root of 13. And again, same thing over here. This is not going to work out because you can't take the power of a positive number. You can't take the fourth power of a positive number and make it negative. So this is wrong as well. So now all we are left with is x to the power of 4 minus the square root of 13 equals 0. So I'm going to first add the square root of 13 on both sides. So now I have x to the power of 4 is equal to square root of 13. Now the square root of 13, this is the same thing as 13 to the power of 1/2. So now if I take the power of 1/4 on both sides, now if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. 4 times 1/4 is 1, so these two cancel out. So now I have x is equal to 1/2 times 1/4 is 1/8, so 13 to the power of 1/8. Alright, so in this video, I'm going to solve the equation 4 to the power of x minus 2 to the power of x is equal to 240. So, my only variable in this equation is x, so that's what I'm going to be solving for. And now for my solution. So I'm going to first start with my equation, 4 to the power of x minus 2 to the power of x is equal to 240. And from here, I'm going to rewrite 4 as 2 squared. So I get 2 squared to the power of x minus 2 to the power of x is equal to 240. Now, I can use the property a to the power of m to the power of n is equal to a to the power of m times n. So in this case, 2 to the power of 2 to the power of x is going to equal 2 to the power of 2 times x. So I have this minus 2 to the power of x is equal to 240. And now I can rewrite 2 to the power of 2x as 2 to the power of x to the power of 2. So I get 2 to the power of x to the power of 2 minus 2 to the power of x is equal to 240. Now from here, I'm going to let 2 to the power of x equal to the variable y. So if I substitute in y for 2 to the power of x, I get y squared minus y is equal to 240. And now I can subtract 240 on both sides. So these two cancel out, and I get y squared minus y minus 240 is equal to 0. So what I have here is a quadratic equation. And to find the solutions of this quadratic equation, I can use the quadratic formula. So if you guys already know, the quadratic formula is negative b plus or minus the square root of b squared minus 4ac all over 2a. So in this case, looking over here, a is 1, b is negative 1, and c is negative 240. So I get y is equal to negative of negative 1 plus or minus the square root of negative 1 squared minus 4 times 1 times negative 240 all over 2a, so 2 times 1. And this simplifies to 1 plus or minus the square root of 1 plus 960 over 2. And this turns into y is equal to 1 plus or minus the square root of 961 over 2. So now the square root of 961 is 31. So I get y equals 1 plus or minus 31 over 2. And now I have two solutions. I have y equals 1 plus 31 over 2, and y equals 1 minus 31 over 2. So my two solutions are 17 and negative 15.